Here I am calibrating the devices at a distance of 2 meters in an environment with open air and direct line of sight between devices. They're oriented in parallel to each other as well. Understandably, these are the ideal conditions. However, I think the vast majority of people carry their mobile phones in their pant pockets. So in most cases, orientation will be close to parallel. From what we know about COVID-19 today, most transmissions happen in open air when there is direct line of sight between people, and walls or doors between devices would have a greater impact on COVID-19 transmission compared to radio waves. Both these devices are totally symmetrical. They transmit a beacon for 1 second and then scan for other device transmissions for a few seconds, and then repeat that in a cycle. I use a random number generator to randomize the scanning interval within a reasonable range to avoid situations where all devices try to transmit at the same time. You can see the bottom green LED is on, meaning that the piPACT code is running. The top green LED turns on during transmission and is off during scanning. As you can see here, simple randomization seems to work pretty well. So for these two devices, the transmission happens at different times. Here I have 2 terminal sessions where we can see RSSI readings get sampled and recorded in the last column. I'll average these readings and then use that as a TX power level to be set inside the beacons. Unfortunately, it seems I can't use the existing TX power field in the beacons since BlueZ doesn't allow any values outside of the -40 to 4 dBm range. Luckily though, we have a few unused fields like major and minor, which were designed to be used in advertising, and we can repurpose them in contact tracing to send arbitrary data such as TX power.